In our last example, we solved a triangle that was in the side-side angle family that had two solutions. In this video, I'm going to solve this one that only has one solution, and we know that from a previous video. But again, I'm going to pretend I don't know that so I can discover why it only has one solution in this video. And I think that'll help you like kind of complete the process in your head. In the last video, we thought about why there were two solutions. In this one, we'll see why there's only one. And I think after you've seen both, it's a good idea maybe to revisit the last example, right? Because I think seeing both of them together will really help the idea sink in. But again, I'm going to start with a picture. I like drawing a 35-degree angle to get started, or something approximately that size. So I got that 35-degree angle there, which makes that A. There's alpha. Little a is going to be over here, however long it is, though I know here it's supposed to be 5.5 inches. Again, not to scale. This is the other side I know, that 5-inch side, which makes this little c, and gamma, which makes this b, beta, and little b. Oh, I think in this video, instead of calling these beta and gamma, I'm going to call them big B and big C the way your textbook does, just so we see that in one example. I really do prefer naming my vertices and my angles different things. I actually, if you're going to use the vertex here at B, would prefer you call that angle B. And like in a geometry class, like a while back, you might have even seen that called angle ABC. ABC, the vertex being the one in the middle. Though in a triangle, I do think it's fair just to use the vertex name. All right. So looking at the given information, it is angle at C I can find first. So I'd think sine of C over that value of little c is equal to the sine of 35 degrees, now over 5.5. All right, so I multiply both sides by 5, and I get sine of c is equal to 5 times the sine of 35 degrees over 5.5. All right, and this is where our TI-83s and 4s come in handy. 5 times the sine of 35 degrees divided by 5.5. And I get that sine of that angle C, or angle gamma, would be about 0.521. And just like in our other video, I am thinking there could be two possibilities for that angle. A first quadrant angle, right, where the sine is about 5.21. That's a nice, happy, acute angle. And then another one over here, right? Sine of this obtuse angle has that same value of 5.21. So let's find both possibilities for C. So I need to find inverse sine of that number. So inverse sine second answer, and I get 31.4 degrees. Or, and I think about this other angle over here. Well, my 31.4 is a reference angle, and that's going to be a 180 minus that 31.4 whatever. And I get 148.6. Well, if I try to think about a triangle that would have that 148.6 degree angle in it and a 35 degree angle in it, add those two things together and I get 183 degrees. 35 plus 148.6 equals 183. All right, well that can't possibly happen in a triangle because all three angles have to add up to exactly 180, and just these two add up to 183.6. They're too big to fit in a triangle. So this must be the case where I just have that one solution and this never hits anywhere else, right? So here we have, that won't work. There's only one solution, and we can just call it C or gamma. I'd really prefer to call it gamma, but C is equal to 31.4. All right, so now I know the only solution I have will have a 31.4 degree angle in it. And now that I know two angles, I can find a third. We can find that angle up there at B. 180 minus 31.4 minus 35 is 113.6 degrees. So now I found my two missing angles, and all that is left to do is to find the one missing side in my exactly one solution. So let's see, little b over the sine of 113.6 is equal to, and again, let's use given information where I can. So alpha and a were given, 5.5 over the sine of 35 degrees. I need to multiply both sides of that equation by the sine of 113.6. and I'll know little b. Little b is about 8.8, and these were in inches. And there we have it. That is our only solution. And I know it's my only solution when I discover that angle is too big. So it is key when I use inverse sine to find the missing angle in one of these side angles that I always think about the other angle it could be. And that's always a 180 minus the one I found, right? Because it's always an obtuse angle over there. The angle I found is always a reference angle to that. I find one through inverse sine, I take that away from 180 to find the other, and then I ask myself, could I form a triangle if I had these two angles? Add them together, something smaller than 180, you can have a third angle. That's a second solution. Add them together and get something 180 or larger, not enough room. That's too big, you can't have a second solution, you only have one solution. In the final video, you will see a case where we have no solutions at all. But that's it for now.